Hey guys, welcome to this tutorial for Unity where I will be discussing 4 important classes that in some way can affect the game object or object's position or movement within a game scene. This is a scripting tutorial and I will be discussing a couple of elements that I would expect that you guys would already be familiar with. For those of you that are less familiar with scripting, we'll be providing a link here and a link here, and that will help you to familiarize yourself with some of the things I'll be discussing. First one is a Unity scripting tutorial for beginners, and just a bunch of basic stuff that you'll be seeing in the examples. And the second one is the documentation for the important classes. It includes other classes that I won't be discussing for today's tutorial, but it also provides a little more in-depth information on these classes that I will be discussing, including extra material that may be a little bit more advanced for this tutorial. Now, let's get a move on. For this tutorial, we'll be focusing on 4 main classes. They're going to be Transform, Vectors, Quaternion, and Mathf. Those will be the ones that I'll deal significantly with position or movement in Unity. So for those of you that don't know what a class is, and to provide some context, a class is a type of blueprint that helps to create components that can be attached to game objects. You'll see this in our examples later on, that the scripting things that we do will be added onto game objects. And as you may see later on in your own work, they can reference one another and create some interesting effects when we work with multiple scripts and dealing with multiple things like different player positions, object positions, and whatnot. And we will discuss this a little further in our examples and definitions. Alrighty, so the first class that we're going to be dealing with today is Transform. Now, Transform is a class that provides you with a variety of ways to work with a game object's position, scale, or rotation, as well as the hierarchical relationship of the parent and child game objects. Essentially, what this means is that we're going to be dealing with a couple different elements that is something you can even manipulate regularly in the Unity scene with the gizmo. However, in scripting, we'll be seeing that you can do some interesting things to create new positions, rotations, and scaling sizes of our game objects. And we'll be seeing that later in our examples. So for the next class that we'll be looking at, we'll be talking about vectors. And vectors are classes for expressing and manipulating 2D, 3D, and 4D points, lines, and directions. We won't be going into 4D. It's in the Unity documentation link provided at the beginning of the video. However, 2D and 3D are going to be shown in our examples later on in this tutorial. Now, vector 2 deals with 2D space. That means that we'll be dealing with X direction, which is left to right, and Y direction, which is up and down. Vector 3 is dealing with 3D space, which means we'll be dealing with X, Y, and Z. Z being the forward and back direction, or depth. This determines the parameters on which our player objects or other objects can move within our game, and it can create some interesting effects when we deal with the vectors between objects or around the space in our game scenes. Something definitely to look forward to. Now, the one thing to keep in mind with vectors, and something we'll point out in our examples, is that vectors have a magnitude, which is a specific number value, and then a direction. Typically, the direction is in reference of the origin. In 2D space, the origin is 0, 0. 3D space, the origin is 0, 0, 0. So that means that if there is a vector that is pointing away into the point 3, 4 in 2D space, it is pointing away 3 to the right, 4 up from the origin. And that is very useful information to keep in mind when thinking about player movement. Alright guys, so the next class we're going to be discussing is Quaternion. Quaternion is a class which represents an absolute or relative rotation and provides methods for creating and manipulating them. This will be dealing with rotation of one object, for example, around another object, and something that we'll be seeing in our later examples in the scripting. It's different from the way that transform can cause rotation, and something to keep in mind But again, it deals with similar position and movement that is a big theme for obviously all these classes that we're discussing today. For the last class, we'll be discussing the Mathf class. This will be a class that deals with a lot of basic math functions. It's a collection of common functions, including logarithmic and trigonometric functions that help with a lot of aspects of game and app development. It's kind of broad use, but it is something that is very important and it can be used importantly in the ideas of object position and movement and so forth, like in the other classes that we discussed. And something that will be very useful in dealing with math, which I know a lot of you probably aren't a fan of. So with that said, we'll jump into the examples for this tutorial.
So what we're going to be looking at here is a couple of things. We have a couple game objects set up in this way. A couple robots over here, turret here in the center. Now, let's see, 1 second here. Let me just change a couple of settings. Okay. Alrighty. So now when we turn on and play the game, what we'll see is this nice little circle of blocks. Now, how they got there and how they formed this nice circle is what we're going to be looking at to start off with this example. And we're going to be noticing a couple of classes. Transform is going to be pretty present in their Mathf class. It's going to be very important to determine how this circle is created. We're also going to be using Quaternion and vectors to determine this creation of this circle. So a couple of things we're going to look at. Let's jump into the script. Let's see. 1, 2, 1. Alrighty, so what we have here is we've created this script and allowed a couple of public variables to be manipulated with. So what we've done here is create a game object that we've designated as prefab. That is where we drop the block so that the script would recognize that as our prefab that we want to manipulate. We've created an integer of number of objects, which is 20, and a radius that is 5. Now, the meat of our focus is going to be inside this for loop. So inside of this, we're saying that we're going to start off with I equals 0, that the maximum number of whatever is going to be 20, and that it's going to be increasing in increments of 1. So the first couple of lines of code, we're going to see that the Mathf function is pretty present in this section. So we're going to use the Mathf function to determine a couple of numerical values. Here we're going to be looking at what is going to be the radian distance dependent on the number of objects in the script or in the game scene. Next two things we're going to be looking at, we're going to find a numerical value for x and z. And we're going to use the math function to look at and find the cosine angle times radius and sine angle times radius to determine two coordinates. And those coordinates are going to be plugged into this new vector 3 called pose. And we're going to say that we want to make this new vector 3 based on the current position of this game object, which the wall scripting is attached to the circle formation, and the new vector 3 is going to be that coordinates away from this position. And the new coordinates for the vector 3 are going to be determined by this x and this z value that we were solving for in this previous two lines of code. Now, we're not going to be doing anything in the y direction because that will just move things up or down if it was negative, and that's not what we want. That will put things in weird positions along the coordinate system, and we'll probably have things get lost under the plane, and then things just end up spawning in the sky and dropping down. That's not really what we want. We want everything to be level and pretty beautiful, just like it was when we just saw it. Now, we're going to be looking at the math function used in this next line of code, which we're going to be using to convert our radian degrees, our radian to degrees, because currently, because of the pi function earlier on when the math was used in this line of code, we made a radian numerical value. But to use Quaternion, we have to have a degree value. And we know that degrees are from 0 to 360. And so we convert this radian to make sure that that numerical value is within those parameters. So by using the math function, we do that. We then finally get to this quaternion that we are using to determine a specific angle of rotation. And we've named this quaternion rot. The quaternion Euler is going to be spinning things along 3 different axes. The x-axis, which would be the first value, the y-axis, which would be the second value, and the z-axis, which would be the third value. Now, again, we don't want things to be moving in the x or z because we don't want things to be going in a circle at kind of like weird angles. We just want things to be spinning in the y direction, which is the vertical axis, because that way it'll go in a circle around that pole. And lastly, what we've done to create this circle is instantiate this prefab at the coordinate vector 3 at, or considering this rotation around the y-axis. And all that together comes together to make this beautifully round circle. And it's really, really cool because like it creates a really beautiful set of objects. We didn't have to do too much work, as you saw in the code. It was very, very simple and straightforward. And because we made some public ints, we can actually manipulate and change this a little bit. Let's go here to circle formation. So let's say I will change this to 15 and the radius to 10. Now, if we look at our circle, it's changed. It's changed to that we can see that there's at least 15 blocks. You can count them out, and they are now a radius of 10 from this position where the turret is. And they are still evenly spaced out, and that's thanks to the use of the math functions to find out the spacing and radians and whatnot, and the Quaternion determining the rotation around this axis. All in all, very useful, very cool, and a lot of it is very intermingled, the workings of the transform vector and Quaternion in this example in math that help to determine how to make the circle. Now, there's another way that we can use, let's say, vectors to determine spacings and whatnot between different objects. And so we'll be going into this next set of script, which is called the avoid script. This will be under our second robot over here. And what we've essentially done, and I'll show you, is we've created these methods that are dealing with a couple different things. So the main thing that we needed to get this kind of going was that we need to figure out what the distance is from object that we designate in our public game object prefab and the position of our game object that this is under. So since I put this under robot 2, what I've done with this vector 3 line is I've determined, or I've asked to find out the position, the vector 3 position of the difference between the position of the prefab and the current position of the robot 2. And that translates into a new vector called distance from object. Now, I'm converting the distance from object into a magnitude because a vector is just, again, a distance plus a direction. But if we get the magnitude, then we can just get the numerical value. And so we've changed that into a float value. And with a couple of more variables mentioned here, what I've done in this next lines of code is determining that if this magnitude of the vector 3, which is, again, the difference from the prefab position and the robot 2 position, which is this current position, transform position, if that is less than the maximum distance, which up here is set to 100, then we shall change the position, the transform. We are translating into a new position. And that new vector 3 is determined by these values set here and the move speed, which is the float up here, and the relative space, which is the world. And just a couple other debugging just in case this code didn't work. But since this is already tested, we know it does. So now, if we go back into Unity scene and we turn on avoid script, we will see that there will be something fun happening. So there our little robot person goes. Essentially what has happened is that we've determined that because there is, the distance, the magnitude of the vector that is between the block and between, I think is the turret, between this game object, the turret and the robot, because it's less than 100, the numerical value 100 that we assigned early on in the scripting, it is going to move away from the turret at a value of negative 0.2f and in the x direction and negative 0.2f in the z direction. So we're not going to be moving up and down again just for simplicity's sake. But what that did was it moved it away and a certain amount of values from the turret and at a certain amount of speed, which I determined also in the script. Now, there's a plethora of different things that we can do with vectors, position concerning the transform, and Quaternion and the math functions. Some very important and useful things to know about vectors, and you can read up on your own, is the dot product and cross product. Something that would be very useful in determining the vectors in consideration of 2 or more vectors. And so it'll be something that's really cool and useful in game development for sure. A bunch of different ways to use math, of course, not just for determining like numerical values in the ways that we did, but also in other functions. Quaternion, again, rotation in reference to another object, very useful, very good techniques to know, and just overall, very good practices.